The mean value theorem, a brief overview and some example problems. This is mostly just review, not an in-depth explanation of the entire theorem itself. If this function is continuous at every point of the closed interval a to b, and also differentiable at every point of its interior a to b, not including the endpoints, then there is at least one point c, arbitrarily called c, at which f prime of c is equal to f of b minus f of a divided by the quantity b minus a. An example, find any value or values of c in a to b that satisfies the equation f prime of c is equal to f of b minus f of a divided by b minus a. So our function f of x is equal to 2 plus cosine of x on the closed interval 0 to pi over 2. First, we're going to differentiate our function. So f prime of x is equal to the derivative of 2 is 0, plus the derivative of cosine is negative sine of x. So f prime of x simplifies to simply negative sine of x. We let x equal c. We have f prime of c is equal to negative sine of c. Additionally, we also know that f prime of c is equal to, seeing our formula down here, f of b minus f of a divided by b minus a. Well, we know that 0 is our a and pi over 2 is our b. So f prime of c is equal to f of pi halves minus f of 0 divided by pi over 2 minus 0. F prime of c is equal to, if we plug pi over 2 into the original function here and 0, we come to the value of negative 0.6366. Now what do we have here? We have f prime of c is equal to negative sine of c, and f prime of c is equal to negative 0.6366. All we need to do now is combine these two equalities into negative sine of c is equal to negative 0.6366. We can get rid of the two negative signs by dividing by negative 1. To find c, which is the goal, to find any value or values of c, we take the inverse sine of 0.6366 to get c. This yields, putting it into our calculator, this gives us c is equal to 0.6901. Same question, find any values of c in a b interval that satisfies the f prime of c equation. Our function f of x this time is x squared plus 2x minus 1 on the interval 0 to 1. Again, we'll differentiate first. So f prime of x is equal to 2x plus 2. Indicate that x is equal to c. We find that f prime of c is equal to 2c plus 2. Now this step may be a little confusing, but what we're doing is simply finding a c value. If this is our a to b interval, we know that some x value, these are both x, a and b are both x, and so c is some x value as well. So any x value here we can simply replace with c. C is just an arbitrary term used in the mean value theorem, so it just refers to a particular x that we're looking for. So we just call it c, and that's why we can replace x with c in each instance. We'll do the same thing utilizing the formula here. So f prime of c is equal to f of 1 minus f of 0. Remember, this is a, and this is b, divided by 1 minus 0. F prime of c is equal to, if we plug in 1, we get 1 plus 2 minus 1. 2 minus f of 0. 0 plus 0 minus 1, that's a negative 1, divided by 1. So we find f prime of c is equal to 3 over 1, which is just 3. Again, combining, canceling out the fact that both of these are equal to f prime of c. So we can set 2c plus 2 equal to 3, because both of these equal f prime of c. So each of them, both of the right sides here, equal each other, since they are both equal to the same value, f prime of c. Find 2c is equal to 1 by subtracting 2 on both sides, and find that c is equal to 1/2.